Hi y'all, this is just going to be a quick reminder about all things linear. If this doesn't feel like something that you just need a quick refresher on, please let me know. We're kind of going from the point that this is stuff that you've seen fairly recently and are comfortable with. So we've got a few formulas that we can work with. We need to be able to calculate the slope of a line, which you should be able to do given a graph or given 2 points on the line. Slope is defined as change in y over change in x, and that's what you're seeing right here. This is nice kind of prelude to calculus notation, pre-calculus notation. There we go. That little triangle is a delta. So delta generally in math is used to represent a change. So that's saying change in y, delta y over delta x, change in y over change in x. And again, you can just get that looking at a graph, count out how much your y changed and how much your x changed. Or if you're given 2 points, you can find the difference between the y values and the difference between the x values and divide. Once we've got a slope, we have 2 forms of lines, equations for lines that we can work with. We have slope-intercept form, y equals mx plus b, aptly named because m in that formula represents the slope of the line, and b represents the y value of the y-intercept. So not just the y-intercept. Remember, the intercepts are points. They have x and y coordinates, but the y value of that intercept. And then last one for us is point slope form. This form just emphasizes an arbitrary point as opposed to specifically the y-intercept. So now we're looking at, let me switch here. If the line goes through x1, y1, any old point on the line, and the slope again is m, then you can just fill in the blanks and you've got an equation, or vice versa. If you're given an equation like that, you can easily pull out what is the point and what is the slope. So we're going to start with given an equation, sketch the graph, and then we will work on given information or a graph, find the equation. Okay, so first example, we have y equals 2/5 plus 3/5 x, and we are supposed to sketch. This is very close to slope-intercept form, but do pay attention. The key is that the slope is always hooked to the x. So this is actually our slope. It's not written in the same order as above. Order doesn't matter. You just want to pay attention and make sure you don't get tricked. So we need to have a slope of 3/5. You can look at that a lot of different ways. Probably the easiest way is to say the 3 is your change in y and the 5 is your change in x. But you could also look at it as 3/5 over 1. If x changes by 1, y changes by 3/5. Or you could even scale it up and say 9/15. If x increases by 15, y increases by 9. So slope is a fraction, it's a ratio, and you can scale it up or down to get different information. But if we just take it as written, I would say if x increases by 5, y increases by 3. And that leaves this value right here to be our b value, which is the y coordinate of our y-intercept. So I'm going to zoom in a bit here and say, okay, if we cross the y-axis at 2/5, so 0, 2/5 is our y-intercept, and then we head off with a slope of 3/5, we should get a pretty decent graph. So we would go over 1, 2, 3, 4, 5, and then we would go up 1, 2, 3, and that would put us at 5, 3 and 2/5, which is 17/5. Okay, so that does give us a second point. We really only need 2 points to sketch a line, although we could follow it out. We could go over 5, up 1, 2, 3 to continue it, and you can even go back 5, so we could make this -3 over -5, back 5, down 3 to continue the other direction. But I want to actually look at this one that I wrote down. This one's actually kind of nice in this problem. Over 1, up 3/5 is the way I would look at that. And that's nice because I can use it right here and say, okay, if I go over 1 and up 3/5, that actually puts me right at 1, 1. And then if I go over 1 up 3/5 again, 1 is 5/5, so 5/5 plus 3/5 is 8/5. And you can get all sorts of points this way. Okay, so given something in this form, y equals mx plus b or b plus mx, the easiest way to graph it is just use that y-intercept as your starting point and then use your slope to continue from there. Do remember that if you ever get stuck, usually the most basic thing people learn for graphing any equation, two-variable equation, is you can make a table. So you could just pick some x values and you could start plotting points. But we are hoping to get this understanding for writing certain types of equations in certain forms, giving us certain pieces of information that are really useful. So slope and intercept from this form. Okay, the second one we have here is actually written in point slope form. And you don't really see this a lot, but I just wanted to point it out that if you get something written in this form and you recognize it, then you can say right off the bat that our slope is -3. Our x1, our x value is +1. Remember, the minus is built into the formula. And our y value is 3. Again, the minus is built into our formula. So I could actually get a pretty nice graph going just by saying, okay, I need to pass through the point 1, 3. And then if my slope is -3, I look at that as x increases by 1 when y decreases by 3. So if I go over 1 down 3, over 1 down 3, I'm going to go back 1 up 3 as well. A little crooked, but there's a graph. Okay, so there's a graph for my equation. So you can actually work straight from point slope form to graph. I would also like to point out that typically when we're writing an equation to answer a question, we would put it in slope intercept form, and we could do that very easily here if you're more comfortable. So I would do a couple of things. One, I would distribute the -3 through. So I would say I have -3x plus 3. And then I would also add the 3 that's over there with the y to both sides. So I'd actually have another +3 over here. And it sorts it out fairly quickly to be y equals -3x plus 6. And from that form, we get one piece of information that's the same. Our slope is -3. Now we know that our y-intercept is at 0, 6, which looks about perfect for what we hit before. So you can just rewrite things back into slope-intercept form anytime you want to graph. Okay, couple more examples. These are really quick. I just wanted to remind you of this. We talked about having point slope form or slope intercept form, but we've got a couple here that don't quite look like they fit that. The first one is y equals -2. And remember, it's great that we're looking at all these forms and kind of memorizing what they tell us, but the bottom line is that an equation is just telling you what's true about all the points on the graph. So what this is saying is that the points don't fit a linear pattern as above. The points all have a y-coordinate of -2. So if x is 0, y should be -2. And if, I guess that doesn't quite work, x is 3, y should be -2. And if x is -5, y should be -2. And what we get here is a horizontal line. So all the way across with the same y value is a horizontal line. Similar to that, we have x equals 6. So again, it doesn't fit the y equals mx plus b pattern, but what it's saying is very simple. It's saying what's true about every point on the line is that the x value has to be 6. So if y is 0, x is 6. If y is 4, x is 6. If y is -10, x is 6. And if we generalize that, what we're saying is that every single point on this vertical line is going to make that true. So remember the vertical, horizontal as well. That's good vocab. That'll keep coming up, and sometimes that's a little tricky for people. Okay, so graphing equations, we're trying to get the equation to tell us the pattern for the points on the graph. And in this case, all of them we've looked at are going to result in perfectly straight lines.